Hello, everyone. My name is Junxuan from Tencent. Today, I will introduce our AI translation system designed for gaming. So, a long time ago, before I deeply researched on this topic, I never realized machine translation is such a difficult problem. Many people may think just the Google translation can solve all of the machine translation problem, but in fact, today machine translation is still a challenge. There are over 200 different languages and dialects in world. Even today's best large language model are so smart, so intelligent, they cannot translate all of those language in real time. So I will first introduce my presentation in 5 parts. At the beginning, I will review the evaluation of machine translation algorithm, and then I will introduce our solution and application cases in real gaming products. There are 3 important stages in the history of machine translation algorithm. The first stage is phrase-based algorithm, and after 10 years, when we enter the deep learning era, the neural network become a better option. And then in 2023, large language model brings the translation algorithm into a new level. The phrase-based method consider machine translation and the statistic method. We first split the input sentences as different phrases and mapping them into targeted language based on the probabilities, which calculate from Bayes' rule. Phrase-based methods have many limitations, like fluency, naturalist. After all, they are just word translation and put the result together. They also have lack of context modeling, and there's no way to add more knowledge or context information to the translation. After a few years with the development of neural network, and people found the encoder-decoder structure was very suitable for machine translation task. And at the beginning, people used RNN combined with the encoder-decoder structure to mapping the input sentences and the target translated result. The basic concept here is like if the input sentence have the same meaning with the translation result, they should have the same mapping in the high-dimensional feature space. And so that we can put the input sentence encoded into the high-dimensional and decoded it back to the translation result in the target languages with the same meaning. In 2017, the famous transformer model published. In the original version of transformer, it was actually designed for machine translation. And it replaced RNN so that people can build the model and train the model with more layers, more parameters, so that it can store more information and learning more data. Since then, the translation models are becoming bigger and bigger. In 2022, Meta built a giant model called NLBB, which means non-language left behind. It applies MOE structure to transformer, and it supports over 200 languages. It was one of the best translation model before the GPT-4. Some researchers found the larger models with more parameters not only have good memory, but also have good learning abilities. With same amount of data samples, they usually have better performance than the small models. So the industry growing direction is becoming trend and build bigger and larger models. In 2023, the large language model totally changed the situation in machine translation. Here is a research report. So people evaluated the translation from GPT-4 based on accuracy and fluency. And they found GPT-4's translation ability is very close to the human professional translator. It is still worse than the senior level of translator, but it's already comparable with the human translator. So here the score represents the error during the evaluation. So the error is small, which means the evaluation result is better. And today in the open source community, there are also many good public LLMs. They can support over 100 languages. So are those models good at gaming translation? The answer is no. The gaming translation is much more difficult and complex than normal machine translation situation. Here's a real example from a gaming chat. So the player is very angry about his teammates. So the first word is a dirty word, and he's trying to tell his teammates that the Sakuba's cloak that is a special item in this game, and if he don't buy this item, they're gonna lose this game very quickly. And we can see the Google Translator cannot translate very well. Google Translate has no idea what is going on here, what is the dirty words, and what is Sakuba's cloak meaning in this game. You can see the translation are missing two important information here. The first is the context information, and the second is the terminology knowledge. In those cases, I will show you how context information reflects the translation results. Well, this girl name is Jano. It's a character from a game. And in German, female and male, they were using totally different verb and article, which means if the gender changes, all the sentences will be different. And if you put this character translated into German, if you don't know the gender of the character, you will get two different translation results. And in Japanese, there are lots of sentence final particle, which put in the end of the sentences to express emotional and personality of the speaker. So if we don't know the context of the speaker, like the age, the background, it's almost impossible to translate those particles. In Korea, the word used to elder people or younger people are totally different. It's called respectful languages. And if we try to translate something into Korea, age is an essential context information to have. Besides the context information, the terminology and the jargon for gaming translation is also very important. Back to the example of Sakuba's cloak, LLM tried to translate into something based on his own understanding, like witch's cloak. It is similar, but not very precisely. Some player, when he played the game, they will not type full name of the terminology item, because when you play the game, you just only have 1 or 2 seconds to talk to your teammates. You may just tap 2 or 3 letters. And so that is abbreviation is also very common during the gaming translation. And in order to let LLM understand those abbreviations, we have to build a mapping between the abbreviation to the terminology. Also, there is one thing like disaster to all the translator. Different games are built from different gaming studios produced by different groups of developers. The definition of the terminology are different, even for the single word. Like Snowfest, some games call it Winterfest, and some call it Snow Carnival. So it's very hard to define which one is the correct translation if you don't have the terminology mapping. Now I will introduce how we build our gaming translator to solve all those challenges. Our solution has 4 parts. The first one is building database, then building a RAG system, which is retrieval augment generation. The third part is fine-tuning the LLM models. Last stage is evaluation and refine the translation results. The first step is building a gaming database, because we need all of those domain knowledge as our context in translation. Most of them was collected from the internet, Wikipedia, and we're using an embedding model to compress them into a vector and store into a vector database. The reason why we need to using vector database is in the next step, we're gonna to search and retrieve those knowledge back. So when we handle the import sentences at the very beginning, we need to build a mapping for all of those abbreviation, nickname, dirty words, and we will replace them with a standard format. And we call it this step hotfix, because through LM can understand most of them. They're very smart, not that stupid. But if we directly put those abbreviations into LM, it will lower our translation accuracy. Next part is retrieval. we will first scan the input sentences and search the vector database and return all of the relevant informations. So that's how we get those context information, domain knowledge, and terminology explanations. We did some experiments about which retrieval strategy is better and best for our translation cases, and how many samples should we retrieve back from the database. This number here in the table it's called blue score, which is commonly used to evaluate the translation quality. And we found using the fusion of the top case modality and the BM25 strategy is optimal for our cases. And we also studied how many examples should be retrieved, because more retrieved examples which will give us more information and probably get a better translation result, but it will take more time to search the database. After retrieval, we have a stage called re-ranking. We're using AIM called Blooms as judge to evaluate retrieval result by calculate the perplexity score. The main idea here is that we only need those high quality information which can really help LM translator to understand the input query. So some low quality information will be harmful for those translator results. And after the ranking, we only select the top, which is a very good example, retrieve them back and put it into the ALM. So we did some experiments that shows this re-ranking operation can benefit to our translation results. The PPL score here is represents the quality between the input query and the retrieved documents. After we get all the stuff from pre-processing, here comes one of the most important steps, prompt construction. Here, right side is our standard version of our prompt. And this step can directly change the translation result. The correct setting is fixed for most of the time. And style instruction is flexible based on the different situation. We can adjust the tone or the character for different character, we need to change the style of the translation results. Glossary examples and translation examples are coming from the retrieval information from last step. And the rewriting query is the result from the hotfix, which will we replaced of the nickname abbreviation and the previous table. So we already have given ALM enough context information, fix all the terminology, jargon for him. So can he solve all of the challenges? The answer is still no. So ALM cannot 100% follow prompt instruction, even you write it very clear. Even you're using the best model, there's no guarantee 100% he will get the correct result. Most of the ALM cannot translate low source language very well. You know, the low source language is meaning, so there's some language have limited data in the internet. You know, when those big companies pre-training their model, like Cloudy, Llama, they use huge amount of the data from internet. But the language distribution on internet is not balanced. So English resources are the majority in internet. And for low source languages like Malay or Indonesia, there are very limited data on internet. But actually, in reality, they have a lot of speakers and players, especially in Tencent games. So we cannot ignore those kind of low resource languages. The solution here is to fine-tuning the LLM for changing the translation results directly from parameter level. To be mentioned, we finished all the fine-tuning and training process in Databricks. We built a training set around 150K pairs. Most of them are collected from the online gaming chats. And some of them was the synthetic data we created for some special topics. And all of those training data are annotated by human translator experts. this data set contains different languages pair, and for enhance the performance in the low resource languages, we increase the ratio for those kind of low resource language in this data. Here are some tricks for preparing the training data. We add some randomization to instruction prompts because we don't want all of those training samples have exactly same instruction. Secondary, we added a terminology information retrieved from database for each pair in the training set, which means the training set is not only contains the query, it also contains the information we collected in the database. To increasing the LLM's robustness to typo error, we add some random typo error to training data. For example, add one more letter or delete one more letter to a word, because in the real life, when people try to typo something to another one in the chat, the typo error is a very common situations. Most of the words are not correct. There will be less one letter, or they will have one more letters, because we want to fit in the training data set to fit in the real distribution of the real world. There are two typical methods to train LLM. One is supervised fine-tuning. Another is the reinforcement learning from human feedback. But RLHF require additional human preference data. For translation, it could be the ranking for multiple translation results from different model. And if you're using ChatGPT, sometimes he will ask you to choose which answer is bad. That's what they collecting the human preference data. Yeah. The base model we have tried for fine-tuning, including the Cohere Aya, Q1, and Llama, and Gemma. And because in our application, we have some latency requirements, so we didn't try the huge size of the models. Most of the LM we tried is below 32 billion. Here are some statistical results. We're using two metrics to evaluate the quality. One is human evaluate accuracy. We ask human translator to evaluate as correct or not, which means the translation can represent the original meaning or not. Another one is called X-Commit score. It was generated by an AI model from 0 to 100, and 0 is very bad, and 100, which means the translation is completely correct. From the results, we can see we compared our fine-tuning model like Aya and Gemma 3 compared with Cloudy and Gemini 2 Flash. And we can see from the results for different language pairs, some open source models can outperform the leading commercial models like Cloudy and Gemini in the gaming translation tasks. Before we get final translation results, we also have a last stage called LQA, which represents linguistic quality assurance. In this stage, we asked another LM to evaluate the results based on the multi-dimensional quality metrics like the correctness, fluency, grammar. In the meantime, we also ask this LM to refine the result to get a better translation. So this task will require LM to have a strong logical reasoning, and we found a reasoning model which have chain of thoughts, like DeepSeek R1, have strong advantages on this task. Usually, we will get better refined results. We have published a paper called TEAR to talk about this framework in EMNLP. So this idea for this stage is like sometimes we need to get a better translation result, and we willing to cost more time, to sacrifice more time to refine this output result. Because in our translation application, we find there will be there will be two different situations. One is online translation, another is offline translation. And in the offline translation, the customers or the product, they may need a very high quality of the translation result. And this LQA requires a lot of response time because it uses a reasoning model. And so we didn't apply it to online chat translation. We only use it in the offline services like a video script translation, but it's still 2 times faster than human review, and the review quality gap between the human and the AI is below 5%. Now I will show you some cases that how we apply our translation system to the real product and the services. By the end of 2024, we already translate over 100 million words across 23 languages pairs, cover 13 games in 3 major categories like shooter, anime, and mobile games. We translate all of those games with gaming UI to different languages pairs. And we also ask the human expert to evaluate our translation result, compare with the GPT-4 and the Google Translate. So the rating is from 0 to 5. 5 points stand for the human level translation. And Google Translate only get average like 2.5, and the GPT-4 gets 3.8 in average. And our translation for most of the language pair is about 4 points. And we also calculate the cost, which compare to the traditional human translation services, and the cost is also reduced 25%. Another application is marketing contact translation, like social media advertisement and the player community. To be mentioned here, the player community translation is much difficult than the online user chat, because some post in the player community is super difficult and it's really long and professional, like academic. It feels like academic papers, and we have. So to deal with those very difficult situations, we have to using different base model to deal with the player community. And this situation is real-time in-game chat translation. And in this case, the latency is the most important thing. And we have to give the correct translation answer within 600 milliseconds. And to achieve that, we not only fine-tune the model, but also quantize it to serve into 4-bit. And so far, by end of the 2024, we have translated 4.5 billion words. And our translation services are very flexible. To any product, we support both API and SDK. And in the performance benchmark, it shows our in-game chat translation is 60% improvement over Google Translation. And for the video translation, in this case, the quality is more important than the latency. That's why we designed that previous mentioned the LQA part. In this part, we have real cases which is from Warframe. And in Warframe asks us to translate their video description. They try to build a brand new account in Bilibili, and we help them to translate all of the description in that video. And as a result, within 2 months, we help them translate delivery 120 videos and help them get 1 million views in just 2 months. So the last part, I will introduce something about the future upgrades. So our AI translation system is still have much space to improve. For example, we can build an AI agent to continuously learn new data from the internet and update him by himself, and update the vector database and learn it himself. Probably he can also update his parameter by himself to learn the new features, new gaming, and new terminology, so that we don't have to try to update every day. And we also could utilize the audio and the image data to extend our model to multi-modality. For example, we can directly translate text message in the picture so that we can make more fun applications to the player community.